You think the sun is massive. You could fit 1,300,000 Earths inside it. Jupiter is over 1,300 Earths. That sounds smaller. It is smaller, but here's what they don't tell you. Jupiter tried to become a star. It ate everything in its path. Dust, gas, rock. It kept growing, kept pulling. It wanted to ignite. It wanted to burn. And then at the last moment, just 1% short of fusion, it stopped. So what do you get when a star refuses to wake up? You get a bomb that never went off. You get a planet that isn't really a planet. And if you fell into it, there would be no ground to catch you. You would just fall forever. Every planet has a surface. Mars, red rock and iron dust. You could stand on it. Venus, volcanic plains hot enough to melt lead. Deadly, but solid. Even Saturn. If you could somehow survive the descent through its clouds, you'd eventually hit something. Somewhere deep down, there's a core. Jupiter has no surface. Think about that for a second. No ground, no rock, no place where the falling stops. 99% hydrogen and helium. The exact same recipe as the sun. The exact same ingredients that make stars burn. But Jupiter never lit the match. So when you fall in, at first it looks almost normal. White clouds, ammonia ice crystals, negative 150 degrees Celsius. Cold, but not impossible. You keep falling. The clouds turn brown. Sulfur compounds mixing with the hydrogen, then rust red, phosphorus, then orange, then black. And you're still falling. But now it's not gas anymore. The hydrogen is too compressed, too thick. It turns into liquid. You're not falling through air. You're sinking through an ocean of hydrogen, an ocean with no bottom, no surface above, no light, just pressure, and it keeps building. Deeper still, the pressure gets so extreme that the hydrogen forgets how to be a liquid. It becomes metal, not solid metal, not liquid metal, something in between, a conducting fluid, metallic hydrogen. Electrons ripped free from atoms flowing like electrical current. An ocean of liquid metal generating a magnetic field 20,000 times stronger than Earth's. This ocean is larger than our entire planet. And it's been down there for 4.5 billion years. This is what happens when a star gives up halfway. The Great Red Spot, 1665. That's the year Giovanni Cassini first spotted it. A red oval, a blemish on Jupiter's surface. He didn't know what it was, just something that shouldn't be there. 1830, still there. 1979. Voyager 1 photographs it. 3 Earths wide. Winds screaming at 400 miles per hour. A hurricane that makes every storm on Earth look like a breeze. 2025, still raging. Empires have risen and fallen. Species have gone extinct. We invented electricity, flight, the internet, and that storm just kept spinning. But here's the thing, it's shrinking, losing about 580 miles in diameter every year. Nobody knows why. In 100 years, maybe 200, it might be gone. And we have no idea what happens when a 400-year-old storm finally dies. We've never seen one end. Jupiter kills from millions of miles away. Its magnetic field is the largest structure in the solar system. If you could see it, it would stretch from Earth to Mars. Trapped inside that field are radiation belts, high-energy particles, electrons and protons accelerated to 99% the speed of light, bouncing between Jupiter's magnetic poles. They've been building up for 4 billion years. Earth has radiation belts too. The Van Allen belts, peak radiation there, about 1,000 rads. Jupiter's radiation belts? 20 million rads per orbit. Jupiter delivers a lethal dose in 3 seconds. Now think about Europa, one of Jupiter's moons, covered in ice, possibly has a liquid ocean underneath, could have life. But Jupiter's radiation hits Europa with 540 rems per day. That's 100,000 chest X-rays every single day for 4 billion years. We're searching for life on Europa, while Jupiter is sterilizing it in real time. Any life that exists there isn't thriving despite the radiation. It's hiding from it, miles under the ice, in the dark, in the only place Jupiter's fury can't reach. The king doesn't protect his kingdom. He poisons it. But here's the thing that doesn't make sense. We might owe Jupiter our lives. July 1994. A comet called Shoemaker-Levy 9 breaks apart into 21 fragments. Each fragment the size of a mountain. They slam into Jupiter. The explosions are visible from Earth. Fireballs 3,000 miles high. Scars on Jupiter's surface the size of our planet. If those fragments had hit Earth, extinction. No question. Computer models have been running for decades, simulating asteroid trajectories, calculating odds. The math says Jupiter's gravity catches about 1,000 asteroids for every one that reaches the inner solar system. For 4 billion years, it's been pulling danger away from us. A cosmic shield. But the same simulations show something else. Jupiter also throws asteroids inward. Gravitational slingshot, chaotic orbits, the three-body problem, no perfect solution. The numbers don't add up cleanly. Jupiter blocks roughly 60% of potential impacts, but Jupiter also causes about 10% of actual impacts. Net protection, 50%. So here's the question nobody can answer. The asteroid that killed the dinosaurs, Chicxulub, 66 million years ago. Did Jupiter catch it and miss, or did Jupiter throw it at us? We don't know. The math is too chaotic. The three-body problem has no clean solution. We can simulate, we can estimate, but we can't rewind time. Jupiter might be our guardian. Jupiter might be our assassin. Most likely, it's both. And we'll never know which version saved us, or which version will kill us next. Jupiter is a catalogue of almosts. Almost became a star, stopped at 99%. Almost protects us completely, but also threatens us. Almost kills everything that gets close, except its moons somehow survive. In 5 billion years, the Sun will become a red giant. It will swallow Mercury, Venus, probably Earth. Jupiter will still be here, still spinning, still crushing, still generating a magnetic field strong enough to break physics. We live in a solar system of accidents, a star that almost ignited, an asteroid belt that almost became a planet, a Mars that almost kept its atmosphere, an Earth that probably should have been hit 1,000 times by now. Everything here is an almost. Jupiter doesn't care what we call it. Planet, failed star, radiation hell, protector. It just keeps doing what it's always done, spinning at 28,000 miles per hour, crushing hydrogen into metal, trapping radiation for eons. Not a planet, not a star, just an unfinished thing, that happens to be 1,000 times more massive than everything else we know, combined. "60 years. 2 camps, both certain. The smartest planetary scientists on Earth argued about. What sits at the center of Jupiter? Half of the best planetary scientists on Earth said Jupiter had no core, gas all the way down. The other half said it had a solid core, dense, compact, the foundation everyone else was built on. Then NASA sent Juno. It collapsed both answers simultaneously. Jupiter's core exists, but it has no edges, no boundary, no defined center. The largest planet in our solar system, 1,300 Earths in one object. And the physics inside it breaks every model we build to explain how planets like Jupiter are supposed to work. To understand what Juno broke, you need to feel how certain everyone was. The first camp had a clean story. Jupiter formed like a failed star, a massive gas cloud collapsing under gravity. No solid center. If you fell beneath the cloud tops, you would never hit ground. Pressure would climb, temperature would climb, and you would still be falling. The second camp had an equally clean story. Heavy elements condense first in the cold outer solar nebula. Rock, ice, iron. They accumulate. Gravity pulls in hydrogen and helium on top, and you get a giant planet with a solid nucleus at its foundation. 2 groups, 2 airtight frameworks, both built into textbooks taught on every continent. Then Juno's data arrived. And the universe didn't pick a winner. Juno doesn't photograph Jupiter's interior. It listens to how Jupiter pulls it. The spacecraft swings within 4,200 kilometers of the cloud tops, and Jupiter's gravity has a continuous conversation with it. Every variation in mass distribution creates a gravitational tug. Changes in velocity as subtle as 0.01 millimeters per second, slower than the hour hand on a clock. Juno detects all of it via Doppler radio signal, pass after pass, orbit after orbit. A mass map approximately 100 times more precise than any previous Jupiter mission. Both camps had their predictions ready. Both expected to win. There is a core. The mass data makes that clear. But it has no defined edge. The heavy elements at Jupiter's center don't end at a boundary. They thin out, gradually, over a region spanning roughly half of Jupiter's total radius. Approximately 70,000 kilometers from center outward. Earth's entire diameter is 12,700 kilometers. Jupiter's core region is wider than 5.5 Earths stacked side by side, and it has no surface. Nothing you could point to and say, here is where the interior ends. This is a direct violation of what the standard planetary formation model requires. To build a giant like Jupiter, core accretion theory demands a solid, compact nucleus, a clear foundation gravity can build on top of. What Juno found is a gradient, a slow dissolve, a center that does not behave like a center. 3 doors open simultaneously. Either Jupiter formed this way, which breaks core accretion theory, or something catastrophic destroyed the solid core after formation, or our physics at these pressures is fundamentally incomplete. All 3 doors are still open. The collision theory felt tractable. A protoplanet, 10 times Earth's mass, hit a young Jupiter at high velocity. The impact shattered the solid core. Heavy debris scattered upward into the hydrogen layers. And what Juno measures billions of years later is the aftermath, a diffuse, boundaryless remnant. The impact scattered the debris, and then the heavy material sank, like sediment settling to the bottom of a disturbed glass of water. A sharp boundary reformed, every time, without exception. The answer came from Saturn. Saturn's rings aren't static. They ripple, enormous waves driven by vibrations deep inside the planet. Researchers asked, what if those waves are Saturn communicating something about its own interior? When they combined the ring wave data with Cassini's gravitational measurements, the analysis required one specific conclusion. Large regions of Saturn's deep interior are not convecting. Something is holding heavy elements toward the center, allowing them to thin out gradually without a clean boundary. Saturn has a diffuse interior too, published in 2021, peer-reviewed, independent of the Juno result. 2 gas giants, different distances from the Sun, different sizes, different compositions, the same anomalous structure. This is no longer a coincidence. It cannot be explained by a collision. If both Jupiter and Saturn share this characteristic, then it's not an accident and it's not an aftermath. It is likely how gas giants form, which means every planetary formation model built on solid cores and clean compositional boundaries needs to be rebuilt. Look at the full scale of what this overturns. More than 5,000 confirmed exoplanets have been catalogued, classified, and modeled using frameworks built on the assumption of solid cores. Cooling timelines, interior pressure profiles, habitability assessments, all derived from models that are now structurally suspect. And the 2 planets used to build and validate those models, Jupiter and Saturn, are the only gas giants close enough to study with the precision Juno and Cassini achieved. The thousands of gas giants beyond this solar system have been labeled using a framework that may not describe what is actually inside any of them. One more layer, Jupiter's magnetic field. The magnetosphere extends nearly 1 billion kilometers behind the planet, large enough to contain Saturn's orbit, generated where pressure exceeds 4 million times Earth's atmospheric pressure, where hydrogen loses its electrons entirely and becomes electrically conductive. The result, a magnetic field 20,000 times stronger than Earth's. And it has features that have never been explained. Stronger in the north than the south. Intense localized concentrations at specific latitudes. 2 magnetic south poles. A configuration that should not exist if the dynamo were operating uniformly. Scientists hoped the diffuse core would explain these anomalies. They modeled it. The diffuse core does not explain the anomalies. It makes them harder to explain. Unknown mechanism, no consensus, active research, no resolution. At both poles, continuous ultraviolet auroras burn without pause, covering regions larger than Earth's entire surface, releasing more energy per day than all of Earth's auroras in a year. Hubble captures them in ultraviolet. We cannot see them with the naked eye. The field that powers them remains unexplained. Beautiful, relentless, unexplained. Here is the precise inventory. We know Jupiter has a diffuse interior spanning roughly half its radius. We know Saturn has the same structure. We know the collision model was computationally tested and failed. We know our planetary formation models require a foundation neither planet appears to have. What we don't know, whether this structure is stable or slowly evolving, whether the formation models need modification or replacement, whether the thousands of exoplanets we've catalogued are structured anything like we believe, whether the magnetic anomalies are a consequence of the interior or a separate problem entirely. Juno was sent to settle a 60-year argument. It settled nothing. It dissolved the question. Jupiter is still out there, interior undefined, boundaries absent, magnetic field operating by unknown rules, auroras burning at both poles without pause. The largest planet we can examine in detail. And its center remains one of the most consequential unsolved problems in planetary science.